All right, so I'm gonna have to start again because for some reason the video stopped. So, BC Calculus, Intro to Power Series. So just like we did in class, right? Today, when we watched the Houston Math Prep video on Intro to Power Series, which will be on, you can find the link either in the calendar or on Schoology. All right, so we talked about what is a power series, but basically a power series is when you have a series where x is a variable and the ace of n's are the coefficients of that series. Now there's two types of power series. You can either have a power series that's just x to the n, where the center is 0, and that's why you don't see anything with x. Or you can have a power series that looks like this, and this is going to be a power series centered at c, so whatever that coefficient is. And c, of course, is a constant, and we're going to call it our center. So a power series may converge for some values of x and diverge for other values of x. So now we're going to actually be determining where is this convergence happening, because we have an x that is involved in our series. So the sum of the series is actually now a function and no longer just numerical values like we had in the previous sections. And of course, when you have a function, it has a domain. And the domain for this thing that looks like a polynomial is the set of all x's where the series actually does converge. The only difference is that f of x above has infinitely many terms compared to calling it a polynomial. Okay? So if we say ace of n is equal to 1 for all n, then the power series is basically a geometric series. And when you have a geometric series, you have a ratio. Now in this case, that geometric series has a ratio of x because you are multiplying by x every time, which is what makes it geometric or exponential. And the series will converge based on the geometric series test when x is less than 1 and diverge when the absolute value of x is greater than or equal to 1. So this we already know. We already know this from the GST, right? The geometric series test. Therefore, the domain of the function would be from -1 to 1, not including -1 and 1 for GST. So, when you have a set of values in which that power series does converge, we call that the interval of convergence. So that means if I plugged in anything between -1 and 1 into this series right here, so if I plugged in anything from -1 to 1 into that series, that will converge. And the distance from the center to the outside of the interval of convergence is called the radius of convergence. So here in this problem, our center is 0. Right? Our center is 0 for a series that looks like this. And if the center is at 0 and you know that your interval of convergence is from 1 to -1, and this is the center, well, the radius of convergence is going to be just one value because it's always stemming from the center. And we denote it by calling it R or ROC. And for the interval of convergence, we're going to call it IOC. So in the example above, the center is 0 and outside the interval was 1. So R is going to be equal to 1, like we just said. So there are 3 different possibilities for the interval and the radius of convergence of a power series to occur. For a power series centered at C, one of the following will occur, and only one of these three things. Either the series that you're dealing with only converges only at C and diverges everywhere else. That means that the radius is 0, because whatever C is, that is the only point that it will ever converge and nowhere else. The series will converge for all x's, and in this situation, the radius of convergence is going to be infinity. So if it converges everywhere, so if any number that you put in there will give you a convergence, then we say the radius of convergence is infinity. And then the third possibility is when you have a series that will converge for x minus c being less than r and diverge for x minus c being greater than r. And then in this situation, the series will converge over the domain of c minus r and c plus r. Okay, this idea is shown here. So if we know that, and we're going to do an example, of course, and we'll look at it. So if we solve for that x minus c, and we notice that, all right, basically we have determined that this guy is going to converge for anything x minus c is less than r. So what this is saying is that from the center, we are going to go positive radius, and it will converge here, and we're going to go negative radius, and it will also converge here. So the ROC is going to be our value from C to R. So this is going to be our radius of convergence. And of course, this will be our interval of convergence. And then it's going to diverge everywhere else. So the endpoints, this is a key factor. The endpoints, if the interval of convergence, in the interval of convergence, may or may not be included. So you noticed in this little picture right here, right? The endpoints were open circles. They could also be closed circles. But in order to find out if they are, we do have to test them individually, possibly using other tests. So one thing you will notice in this section, in order to find the radius and interval of convergence, we're going to be using the ratio test. You can also use the root test. On very rare occasions does it come up for us to use the root test, especially on the BC exam. So let's put this to work. So let's find the radius and interval of convergence for the following. So when they say find the radius and interval of convergence, we're going to use the ratio test. And the reason I know to use the ratio test is because I noticed that this is a power series, right? There being an x means that this is a power series. So we're going to use the ratio test to first determine if this thing does converge on an interval, or does it just converge at the center. So before we do anything, let's determine what the center is. So in this problem, obviously the center is 0. So just going through these, part B, what's the center in B? Hopefully you notice that it's 5. The center in C is going to be 3. Okay? And so on. The center here is going to be 0. The center in this problem is also going to be 0. And we'll come back to those in just a sec. So let's use the ratio test. So we're going to do the limit as n approaches infinity of the absolute value of x to the n plus 1 over n plus 1 factorial times n factorial over x to the n. All right, keep it going to simplify, right? we got limit to the x to the n as n approaches infinity of x to the n times x. I'm breaking up these things. Now, which one would make more sense? Turning n plus 1 into n or turning n to n plus 1? Hopefully at this point you figured out that it's the bottom one, so n plus 1 times n factorial. And we got n factorial on top and x to the n on the bottom. So the point of all that was so that we can cancel out those factorials and the x to the n's. So now you are left with the limit as n approaches infinity. Absolute value is very important in ratio test. We are left with x over n plus 1. So now when we plug in infinity into this, right, you are basically left with, and remember you're plugging in from n to infinity, so your x is staying x. N plus 1 infinity is basically x over infinity. And we know any number, so anything that I plug into this, because this is going to be a interval of numerical values over infinity, will always equal 0. And 0 is less than 1. Therefore, this guy converges by the ratio test. So now the question is what is the interval of convergence? And the radius of convergence. Well, x can only be a number, right? So x can only be a number. And when x can only be a number, and you know that you are plugging in a number in to this limit every single time, it doesn't matter what that number is, okay? Whether it's a negative or a positive. Anytime you plug in a number here, you're going to end up with 0. And 0 will always be less than 1. Therefore, it will always converge. So this is an example where the interval, the radius of convergence, or the ROC, is going to be infinity. And the interval of convergence is going to be every number from negative infinity to infinity. So no matter what I plug into this x, it will always converge. That's basically what we figured out here. All right, let's go to example B. So example B looks like an alternating power series, right? So first off, determining that this is the center is 5. I know for sure it will converge at 5, or x equals 5. Okay? I know this thing will converge at 5. So remember, with any alternator and the ratio test, we're going to remove the alternator. And then we're going to rewrite this. X minus 5 to the n to the 2n. And we're going to perform the ratio test again. So limit as x approaches infinity. Absolute values. You cannot forget the absolute values on the test. To the n plus 1 over n plus 1 to the 2n plus 1 times n to the 2n over x minus 5 to the n. Simplified, right? To see what we can cancel out is x minus 5 to the n times x minus 5. N to the 2n, all of that over n plus 1. 2 to the n times 2 times x minus 5 to the n. So hopefully you recognize that the x minus 5 to the n's cancel out, The two ends cancel out, and you are basically left with the x minus 5. So let's write this out. You're left with x minus 5 times n over n plus 1 times 2. All right. So remember that you're taking the limit as n approaches infinity. Okay, so I'm gonna separate some things here to make sure that we are analyzing the correct things. And what I'm gonna separate here is gonna be the n that's left over up here and the n plus 1. I'm gonna put those together. And then I'm gonna multiply that by x minus 5, and I'm gonna multiply that by 1/2. Because this is the part that I'm finding the limit for. Okay? And if you remember, when it comes to limit properties, I can break this thing up, right? I can do the limit as n approaches infinity of n over n plus 1 times the limit as n approaches infinity of x minus 5, or let's just, x minus 5, times the limit as n approaches infinity of 1/2. So, mathematically speaking, this part right here, when you plug in infinity, remember you care about the dominating terms, and that just ends up being n divided by n, so you end up with 1 times the limit as n approaches, let's just move this guy over, it's a little bit easier, times the limit as n approaches infinity of 1/2, which is just 1/2 because there's no n to plug in infinity. And remember, all of these are staying in this absolute value, okay? Times this part right here, again, you're plugging infinity into n. There is no n here. So you're basically just going to be left with x minus 5. And that has to be less than or equal to 1, right? To converge. So this is what I mean when you end up with a possible interval of convergence. So let's clean this up. We got 1 times 1/2 times x minus 5, which is just going to be 1/2 times x minus 5, absolute value less than 1. So this is like a compound inequality. So when you rewrite this in order to solve for x, like we did in Algebra 1 way back when, right? You basically would say that x has to be greater than -1 because of that absolute value, and less than 1. This is what we are testing. Where is x going to be greater than, right? Where is this r? Because that's what this is. This is our ratio. Greater than -1 and less than 1. And you just solve this like you did way back in algebra. So you're going to multiply both sides by 2. So now you got -2 is less than x minus 5, which is less than 2. Add 5, right? Add 5 everywhere so that we have -2 plus 5 is 3. 2, 7. So this thing will converge, okay? This thing will converge because there is a ratio, and there's a ratio that allows us to solve for x to be less than 1. So as long as x is going to be somewhere between 3 and 7, this thing will converge. Now, the question is 3 and 7, are they included? Are 3 and 7 included? And the only way to test if 3 and 7 are going to be included is we got to test the endpoints. So we're going to test them. So we're going to test the endpoints. And first, let's test x equals 3. So we're going to take this x equals 3 and we're going to plug it back in to the original problem, to the original series. And we got -1 to the n plus 1. We're going to plug in 3. So 3 minus 5 is going to be -2 to the n over n to the 2n. And we're going to test this. So when you do test this, you guys are not going to have enough space to test this. So when you do test this, you notice that this is an alternator. So we're going to remove the alternator. So we're going to have the series of -2 to the n over n to the 2n. And you notice that the 2n's will cancel out. So you're left with just a series that looks like this. -1 over n. And hopefully you've recognized now that this is basically a P series, specifically a P series where P equals 1, aka a harmonic series. So this diverges, right? So this guy diverges because it's a harmonic series. You test 7, okay? You end up with, I'm going to remove the alternator right off the bat, and when you plug in 7 minus 5, you end up with 2 to the n, positive, over n 2 to the n, which again is just going to be 1 over n. This is P equals 1, which also diverges because it's harmonic. So this tells us that 3 and 7 are not included. So how do I write my interval of convergence? Well, my IOC is going to be written as 3 to 7. And then my radius of convergence is basically from the center. So this is where the center is important. The center is 5. And we knew that we went out to 7. And we went down to 3. And you notice why the center is important. Because there is a radius of 2 to 3 and to 7. So our radius of convergence is going to be 2. Okay. I'm going to skip C in the video notes. Let's not skip C in the video notes. Okay, let's do C. So again, I know this is a power series. I know it's centered at 3. So I know that this thing does, if it diverges everywhere else, it definitely converges at x equals 3. So let's see if it does converge anywhere else. So ratio test it is. Limit as n approaches infinity of n plus 1 factorial times x minus 3 to the n plus 1 divided by n factorial times x minus 3 to the n. Absolute values. Clean this up. We've got n plus 1 times n factorial. I have to delete some of this stuff. Times x minus 3 to the n times x minus 3. All of that over n factorial times x minus 3 to the n. So the n factorials cancel out, x minus 3 to the n cancels out, and you're left with, let's erase a few more things, and you are left with the limit as n approaches infinity of n plus 1 times x minus 3, all of that over nothing, over 1. So if I was to plug in infinity here, right, you will end up with infinity times x minus 3. And infinity times x minus 3, remembering that x will always be just a number, is always going to be infinity. And infinity is not less than 1. And when it's greater than 1, because infinity is greater than 1, it diverges by the ratio test. And if it diverges by the ratio test, that means it diverges everywhere except at x equals 3. So our interval of convergence, we would just say it's just 3. And when it diverges everywhere else, our radius of convergence is going to be NA or 0. Okay, not applicable. We don't have one. I'm going to leave D and E for you guys to try and come in with questions tomorrow. I will say that the interval of convergence for this guy is going to be it is going to converge on an interval. Okay, it is definitely centered at 0. And you do have to test the endpoints once you get them, okay, to see if they are included or not. And then same thing down here. You do have to remove the alternator, perform the ratio test, and test the endpoints and see what you get. All right. Good luck.